Hey guys, today we're going to do section 4.4. Tomorrow we'll finish it up with 4.5. So we're going to move into actually solving equations. The first way, and probably one of the easiest ways, is to get a common base. Because if your bases are the same, so like if I had 2 to the 4th equals 2 to the x, you know x has to be 4. So if the bases are the same, you know the exponents have to be the same. So this is probably the easiest route to take, is to get a common base. So here I know, I look at these numbers and I know I can get a base of 5. So this already has a base of 5 to the 3x minus 6. 125, I can write it as 5 cubed. Now I have that common base, so I know 3x minus 6 has to equal 3. I know the exponents have to be equal, and you can forget about those bases. And then add 6 to both sides, and you get x equals 3. Same concept here, except for on this one, you got to think a little bit, right? What would be a common base? We're actually going to use 2. So instead of 8, I'm going to write it as 2 cubed to the x plus 2. And instead of 4, I'm going to write it as 2 squared to the x minus 3. Power to a power, we multiply. So we have 2 to the 3x plus 6, and 2 to the 2x minus 6, right? Distribute. Now we have a common base. Now we know our exponents should be equal. So 3x plus 6 has to equal 2x minus 6. Subtract 2x from both sides and subtract 6 from both sides. So you get x equals negative 12. Alright, so get a common base if you can. If you look at the next one, you can't get a common base with 5 and 134. So what else can you do? You can do logs or natural logs. So here I can take the natural log of both sides. That's a 5. You can take the natural log of both sides. 5 to the x equals the natural log of 134. Here we can use our exponent, our power rule. Bring that x out front. Natural log of 5. Natural log of 134. And we want to get excellence. We're going to divide both sides by the natural log of 5. And then you let your calculator do the work. So here x equals, you would type in natural log of 134. Make sure you close that parenthesis in your calculator. Divided by natural log of 5. When you type it in, you should get about 3.04. About 3.04. So make sure you know how to type that in. You could also use common logs. When I see a base of 10, I want to use a common log. So we're going to say log of 10 to the x equals log of 8,000. Bring that x out front. Log of 10. Log of 8,000. And log of 10 is 1. All right, 10 to what power is 10? 10 to the first. So we have x equals log of 8,000. And again, you're just going to type that in your calculator. So you wind up getting about 3.90. All right, so you can use some calculators, especially when they're not as nice. The next one, you want to get that alone, right? You want to get your powers, your exponents alone. So let's add 5. Right, think of it, we're not doing anything different right now. We're going to divide both sides by 7, right? We're isolating our variable. E to the 2x. And then again, I see e, I want to say natural log. So natural log of e to the 2x equals natural log of 9. I'm going to bring this over here. I'm going to bring that 2x out front. Natural log of e equals natural log of 9. Now here, natural log of e is 1, right? E to what power is e? E to the first. So you have 2x equals natural log of 9. and we're going to divide both sides by 2. So what you're going to type in your calculator is natural log of 9. You're going to close those parentheses and divide by 2. You should get about 1.1. 1.1. Now this one, we actually got something going on both sides, which is okay. We're still gonna, let's do our natural log. Natural log of 3 to the 2x minus 1 equals natural log of 7 to the x plus 1. Because again, 3 and 7, I don't know a common base for those. 2x minus 1 comes out front times the natural log of 3. And x plus 1 comes out front times the natural log of 7. Now here it's kind of hard because I got to get x alone. Remember, this is a constant. It's a number. Natural log of 3, you could type it in your calculator. So we're going to go ahead and multiply that. So we have 2x times the natural log of 3. We have minus the natural log of 3 equals natural log of 7 times x, so x times the natural log of 7, and then times 1, which would be the natural log of 7. Let's get our x's to one side. So we're going to subtract these over. We're going to add, well, I'll do it 2 steps. 2x natural log of 3, we're going to subtract that minus x. Still have that minus natural log of 3. So I subtracted x natural log of 7 from both sides. Again, you want to get your x's over here, so let's add that natural log of 3 over. So we got natural log of 7 plus natural log of 3. Now here, think about GCF, right? Think about GCF. You can factor out an x. So if you factor out an x, you're left with 2 natural log 3 minus natural log of 7. Right, we just factored an x out of both of these. I'm going to leave this side alone over here. And now you can get x alone. Divide by 2 natural log of 3 minus natural log of 7. Divide by 2 natural log of 3 minus natural log of 7. And you'll be left with x. So this is what you're typing in your calculator. Again, make sure this whole thing stays in the numerator, this whole thing. If you use parentheses, close them, all that good stuff. All said and done, you should get about 12.11. 12.11. Next example. You can also factor. So don't forget what you already know about factoring. When you see something that looks kind of quadratic-y, if that's even a word, but when you see something that has that form, you can factor. So if we do this, we have e to the x times e to the x gets me e to the 2x. What multiplies to 7 and adds to -8? -7 and -1. And then we can set up our two equations. E to the x minus 7 equals 0, or e to the x minus 1 equals 0. So e to the x equals 7. Take the natural log of both sides. We got x natural log of e equals natural log of 7. I'm running out of space here. Natural log of e is 1, so we get the natural log of 7. So we get x equals the natural log of 7. Which, if you type that in, is about 1.95. 1.95. Here we're going to add 1, e to the x equals 1. We're going to take the natural log of both sides. So we're going to bring that exponent down. Natural log of e is 1. It's nice to know that one, right? E to what power is e? 1. So we got x equals natural log. Oh. Natural log of 1, my bad. And then e to what power is 1? E to the 0. So x equals 0. X equals 0. You can also solve logs, right? Logarithmic. My advice is to put it in exponential form. This is saying 2 cubed equals x minus 4. 2 cubed is 8. equals x minus 4. Add 4 to both sides, x equals 12. You do want to check these. So we're going to do a little check. Log base 2 of 12 minus 4 is 8. Double check. 2 cubed equals 8. That's good. So we like that answer. So always go back and double check these. Here I'm going to divide both sides by 4. So we get 2. Remember your natural log, your base is e, so e squared equals 3x. And divide both sides by 3, so e squared over 3. And again, you can just, oh, that's a squared. You can still plug this in and check for natural log of 3 times e squared over 3 has to equal 8. So we've got 4 natural log, those cancel, of e squared has to equal 8. Natural log of e squared, e to what power gets me e squared? E to the second. And 4 times 2 does equal 8, so that is an answer. So always double check these. All right, next one. Let's go ahead and combine these. Addition we combine with multiplication, so log of x squared minus 3x equals 1. And then put it in exponential form, so 10 to the first power equals x squared minus 3x. And I see a quadratic here, so I'm going to make it equal 0, so subtract 10. And we're going to factor. So what multiplies to 10? Negative 10, sorry. We got 5 and 2, and we want them to add to negative 3, so negative 5 and positive 2. So my answers are x equals 5 and x equals negative 2. Again, you want to check your answers. So let's do log 5 plus log 5 minus 3 is 2. Multiply, so we got log of 10 equals 1, which is true. So that is an answer. Next one, log of negative 2, and we can actually stop right there. There is no number you can raise to an exponent and get a negative. Okay? You can't raise it to an exponent and get a negative. So we're actually gonna stop there. All right, we're not gonna use that negative. Next one, let's combine natural log of x minus 3. Natural log, subtraction says division, 7 minus 23, that's a 3, over x plus 1. Well, you know these are both natural logs, so if the natural logs are the same, this must be the same. So x minus 3 has to equal 7x minus 23 over x plus 1. Let's multiply both sides by x plus 1, so x minus 3 times x plus 1 equals 7x minus 23. So here we've got x squared. It's a plus 1, right? Yeah. So this is x, sorry, my handwriting is awful. X plus 1. Okay. What do we got? X squared minus 2x minus 3 equals 7x minus 23. 23. This is just getting worse. Subtract 7x from both sides, we get negative 9x. Add 23, we get 20. And we're going to factor. X minus 4 and minus 5 makes 20 and 9. So we get x equals 4 and x equals 5. Plug both of those in and check, but they do both work. All right. There will be a part 2 to finish this off because I kind of ran out of time.